Hi, welcome back to the channel. So in this video we are going to see a derivations of half-wave rectifier. So what are the points to be discussed here is under the first one, the derivation, we will call it as average or the DC load current. That is, we will write this as average or DC load current. So this is represented by I average or IDC. So for this, we'll take the help of this sine wave. So how this sine wave is? So here we can write this sine wave as, which is current I is equals to Im sine omega t, where we can define this omega t is greater than 0 and less than 2 pi. So this is a normal current equation we can write. That is IL, or here we can write I output, whatever it is. You can write it as I, that is IL, right? So the load current or the load voltage which you got at the half-wave rectifier. So if you recall, the half-wave rectifier can just have like this. So that is, we have considered here. So we have written this as RL and it is VL. It is nothing but it is since directly proportional to IL, we can write it as IL, right? So I want to have this I average or IDC. So for this, how we can write is, we can first we'll take it from complete cycle 0 to 2 pi. Later we'll see what is going to happen, right? So IDC, how we can write IDC? DC is nothing but here at the output side. It is for complete cycle, the area under the curve. What is the area under the curve? 1 over 2 pi, and it is 0 to 2 pi multiplied by I into dt. So in this case, the dt is can be written as d of omega t, right? So that I is nothing but in this case IL, right? Next, after that, start substituting. 1 divided by 2 pi, it is 0 to 2 pi, and it is IL. What is the value of IL? It is Im sine omega t, right? So this is what the IDC will be having. But here we should think about what is the output we are getting. Output we are getting for 0 to pi. So we should write this as 0 to pi of Im sine omega t, right? So from this, what is the constant? Im is a constant, take it out. Im divided by 2 pi, and it is 0 to pi sine omega t, right? So this can be written as Im divided by pi, and what is the integration of sine? Integration of sine is minus cos omega t, and the limits are 0 to pi. So how to solve this? Im divided by pi minus, I will take it out. So it is cos minus pi t, right? So cos minus pi, and here you can write it as minus of cos 0. So what is the value of this? Minus Im by pi. What is the value of cos pi? It is not minus pi. Cos pi value is minus 1, and here it is minus 1. Minus 1 minus 1 is minus 2. So minus 1 minus will get cancelled. So what is the value you will get? 2 Im by pi, right? So one second. It is Im by 2 pi. It is Im by 2 pi. So here 2 and 2 will get cancelled. So you'll end up with what? Im by pi. So what is the I average or IDC value is? It is nothing but Im by pi, right? So this is how we should derive the I average or IDC for a half-wave rectifier, right? So once we got the first one, I average or IDC, VDC is very easy, right? Only IDC means you should take this waveform and we should do like this. If it is VDC, so VDC is very easy. So I will write here how VDC will be there, right? So here it is IDC. So VDC can be written as, so IDC into RL. What is the value of IDC? Im by pi divided by RL, because we have used the Ohm's law here. V is equals to R into I. So VDC value is like this, right? So this is the second derivation, that is about VDC, DC voltage, right? This is the first one, IDC. IDC value is Im by pi, VDC value is Im by pi multiplied by RL, that is a load resistor, right? So now once we have found, I will write here IDC, we found what is VDC, next we will find what is IRMS, right? Later we will see up to the efficiency we can see, right? So now, so I'll pick up the next point, third one. Like this, they may give anything in your competitive examinations with the help of the formulas. You can solve a problem, or in your introduction to electronics or basic electronic concepts. So anything they may give the derivations of half wave rectifier as well as the full wave rectifier. So we have chosen here the first one, half wave rectifier. So how to write the third point? The third point is about IRMS. So we will pick up this. What is that? IRMS. We know that. What is that? RMS stand for root mean square, right? What exactly we should do? We should take the square of this, then we should take the mean of this, then we should take the square root. So here what we can best write is, it is under the square root. So under the square root, mean, how we can write the mean? It is over the 1 complete cycle, 1 over 2 pi. Then it is 0 to 2 pi of this squaring. What is squaring? The squaring is Im square multiplied by sine square omega t, and it is dt. So this is what the concept is, right? So now we should solve this. We should, if we solve this within the integration, then we will get what is IRMS. So I will call this as third one. IRMS is equals to, right? So it is Im square constant, take it out, so that it is going to be Im only, that is under the square root is there. If it comes outside, it is going to be Im only. Then this as it is 1 divided by 2 pi, it is 0 to pi sine square omega t, and it is dt, right? So next after that we should see, and here we are interested in this 0 to pi, it is not 0 to 2 pi. So here, and also it is sine square theta is there. So two things, sine square theta can be written as 1 minus cos 2 theta whole divided by 2, right? And also we can write here Im square root of 1 divided by 2 pi, then it is 0 to pi 1 minus cos square 2 times omega t whole divided by 2, and it is d omega t, right? So for this d omega t, right? So we should solve this within the integration, right? So it is Im same 1 by 2 pi. So now we should do the integration for 1 by 2 of d omega t. So it is half omega t minus, what is cos square 2 omega t, 1 minus cos square 2 omega t, 1 minus, not 1 minus cos, it is not cos square. So it is 1 minus cos, that is, we should write it as cos 2 omega t by 2. So it is going to be integration of cos is minus sine, so not minus sine, plus sine. So it is cos 2 omega t divided by 2 is there, so it becomes 4. So it is 0 to pi. So we have used this integration of cos theta is sine theta, not minus, it is plus, right? So now we should solve this, so that we got Im square root of 1 divided by half, and look at this, half of omega t is there. For this we should substitute pi. So I will get pi by 2 for omega t. So omega t is considered as t here. What is sine 2? 2 into pi. What is sine 2 pi? Sine 2 pi value is 0. Sine n pi value is 0. So this value is 0. So this whole thing is 0, right? So you will end up with only this part, right? So now pi and pi will get cancels. 2 2s are 4. So you will get here Im into 1 divided by 4. So if it came out Im by 2, you will get root of 4 is 2. So what is the value of IRMS? IRMS value is Im by 2 you will get, right? So this is how we should solve. The basic thing is, concept is this one only. With the help of this IL value only, we are taking this. Root means square, means it is squaring this term. Main means 1 by 2 pi and taking the square root. That is the meaning of this. So that we will get Im by 2. Then after that, we will calculate what is efficiency. To calculate efficiency, now we want the power output as well as power input we should get. That is called as power output as PDC and power output as PAC. So we should find these two so that we will get the efficiency, because the efficiency is power output divided by power input. So we'll take that help so that we will get what is the efficiency of a rectifier, means by how much percentage. At the end we will convert into percentage and we will put it. So efficiency of a rectifier we will calculate. So we have calculated what is IDC, Im by pi. It is Im by pi into RL, right? It is Im by 2. Now we are calculating what is power with respect to DC. So how to write power? I square into RL. Since it is DC, we can write it as DC, right? What is IDC? IDC is Im square divided by pi square into RL. So it is PDC, right? Fifth one, PAC we should write. PAC means it is I RMS square. I square RMS, right, into RL. What is I square RMS? So it is Im square by 4 into RL. So this is PAC, right? So now we should find the rectifier efficiency. That is, how to write the rectifier efficiency? DC output power divided by AC input power. So what is the DC output power? So it is Im square divided by pi square into RL, that is the numerator. What is the denominator? AC input power. What is that? Im square divided by 4 into RL. Which are the things which are get cancels? RL and RL, Im square and Im square, right? So if this will get cancels, 1 by pi square and it is 1 by 4, right? Denominator is numerator, so it is 4 divided by pi square you will get, right? When you are writing the efficiency, you will write efficiency in terms of percentage. So this you should multiply it by 100. So you should multiply it by 100, right? So efficiency 4 by pi square, and you should calculate this. So we are going to get this as 40.6%. 4 by pi square into 100, you will get it as 40.6%. So the meaning of that is, here the power, that is efficiency, if I am sending you 100 at the input, I can able to perform only up to 40.6%. That is, conversion from AC to DC is only 40.6%. The remaining 60% is going to be wasted. So, right? So that is a efficiency, 40.6%, right? So like this, we can have the one more, that is with respect to, here I will write efficiency, which is 40.6%. Next, after that, fifth, sixth, it is 6, right? So next one, seventh one, we will be having one more. We will call it as ripple factor, that is R, that we will see in the next video with respect to the half wave rectifier. Followed by, we will see the full wave rectifier, the same set of derivations. Only the thing is, it is going to be changed. Input is like this, it is AC and it is DC. That is, we will call it as pulsating DC. It's an impure form of DC. See that in the next video. Thank you. Stay tuned to this channel. Click on the bell icon for the next one.